is still open. But they are very cute. They will cut me at 45 sharp. So. Okay, I don't see anybody else is coming, so I will probably start. Welcome, everyone. My name is Jacint. I only use my first name because it makes so much easier. I work as a storage architect pretty much for 10 years now. So my focus is on storage, so I have no idea what I have to do with the hyper-converged infrastructure. It has storage, by the way. So any of you who already have an HCI solution, a hyper-converged infrastructure solution from any vendor? Anybody? Okay, nice. Anybody is planning it? Or looking at the options? Okay. So the rest of you is just interested that what is it about, or what can we bring on the table?
Dreaming of.
Dreaming of, okay, nice. I think you run ahead for my next question. Is why you are not having an HCI, and to be honest, without asking the question, in 99.9% of the cases I get because of the price. Is that the case here as well? I think we have an agreement. Okay. Okay, let's see what we can do anyway. Because that's a fact. I cannot give you reasons why typically hyper-converged infrastructure solutions are not cheap. Maybe I don't know. Maybe it's the cool factor, or maybe it's new, or maybe it's the solution is complex to build. It is a fact that if I'm looking at from a specific point of view, it may look more expensive than others. Obviously, there are very nice analyses which can show that how it's more cheap than infrastructure you build yourself. But yeah, it's a completely different acquisition from pricing point of view than a standard infrastructure. So let's see what a hyper-converged infrastructure is. A hyper-converged infrastructure is basically a full data center capable to deliver a virtualized environment. So that's basically a reason. So let's say you want to run a VMware infrastructure and you need a compute network and storage for this VMware infrastructure to be able to run your VMs, to run your applications. And you have a couple of options. You can go ahead and buy servers and storage and build your own data center. You can go ahead and check some of the vendors who are offering converged infrastructure solutions, so buy everything from a single vendor. Or there is this new thing which is called hyper-converged, which promises an easy deployment of a VMware or other virtualized solution. And it has a lot of promises, to be honest. So obviously you need to justify the higher acquisition point with promises. But basically what it offers is an easier to deploy and easier to manage end-to-end infrastructure to run your virtualization. So that's what a hyper-converged infrastructure is about. So obviously. So interestingly, I have a discussion with a lot of customers and partners and so on. And partners and customers, unless they are very much focused on NetApp and very much following the blogs and the PR articles and everything like that, majority of the customers and partners have no idea that NetApp actually has a hyper-converged infrastructure, which is not surprising because we as a company, we spend way more money on engineering than marketing. So unless you are reading all the blogs, or if you are visiting NetApp events, or you are listening to NetApp dedicated podcasts, probably you are not aware of that NetApp brought a new product a year and a half ago, which is the NetApp HCI. Obviously, we were not the first on the market. So when we joined the hyper-converged market, basically we were the 37th vendor on the market. Okay, so there are, at least at that point, there were 36 other vendors offering some sort of hyper-converged infrastructure solutions. which means two things. One of them, obviously, you are late, right? If there are 36 other vendors already doing it, you are definitely not the first. The second thing is what I call Microsoft don't always happy with this idea what I share, but I call this the Microsoft type of innovation. When you are looking at the market, what the market is doing, and you figure out what others may not be doing the perfect way, and you learn a lot from these approaches, and then you build your own solutions where you are thinking that you can fix the problems or you can fix the challenges what other vendors are facing. So this is what we did. We looked into the market and the 36 other vendors to figure out that how they are building their solutions and what kind of problems they are trying to solve. And we built our own hyper-converged infrastructures, and we decided to focus on three challenges and build our infrastructure around this. And basically, I will focus on performance and flexibility in this presentation, because consolidation is basically a side effect of having performance and flexibility. Okay? So let's see what NetApp HCI is. NetApp HCI is a VMware-based hyper-converged infrastructure. I like to emphasize it's a VMware-based hyper-converged infrastructure because this is what we are currently focusing on. I'm not saying that you cannot take our HCI-based physical infrastructure and you cannot put KVM on it, or you cannot put Hyper-V on it. We will just not do an automated deployment of a Hyper-V infrastructure on our HCI platform. If you wish to run, let's say, Hyper-V on it, it's absolutely supported. So at the end of the day, we are talking about servers and storage and things like that. So it's absolutely fine, it will work perfectly, but it's not where we are focusing. The reason we are focusing on VMware is extremely simple. If you look at the virtualization market, over 90% of the market is VMware. So we could focus on the Microsoft Hyper-V market, which is something like 9% of the virtualization market, but it wouldn't make a lot of sense. So as of now, the automated deployment, the NetApp deployment engine is going to install you a new VMware environment when you wish to try or implement a NetApp HCI solution, or it can integrate into an existing VMware infrastructure. So if you already have your own, you are not forced to create a new vCenter with the new HCI solution. It can absolutely join into an existing VMware solution. We started with an all-flash storage. So yes, it's 2019. So as I mentioned, we started a year and a half ago. So that was the end of 2017. And starting something like a hybrid solution or spinning drive-based solution at the end of 2017, it just doesn't make sense. So it's all-flash. Obviously, that's one of the outcomes that we are using our flash storage inside the hyper-converged infrastructure, is that we can focus on performance, we can focus on consolidating business-critical applications, because we actually have the performance to run these applications on our hyper-converged infrastructure. Obviously, we offer robust data services, because guess what? We are a storage company for 28 years now. So we have an ecosystem to build into. We have cloud integrations, we have integrations with backup vendors, we have remote applications, synchronous and asynchronous, and all of these things which are really, really hard to build. If any of you may have the idea that the storage market is very good, so I hire some engineers and build a storage solution by tomorrow, it's absolutely possible. So you can build any storage-based operating system based on Linux types, things like majority of the new storage solutions are based on Unix operating systems. It's quite easy to build a storage. But the ecosystem around it, the replications, the cloud integration with backup vendors, that's the harder part, the ecosystem around it. And that's basically what we have already. Obviously, building block architecture, so you wish to pay as you grow. Although this is one of my favorites, so as long as I remember, so I'm working in IT over 20 years, but pay-as-you-go is one of the biggest wishes, and pay-as-you-go is one of the biggest promises what everybody is trying to offer in their solution. And the only thing which can really give you a pay-as-you-go is the cloud. if you go to the cloud, basically you pay as you go. If you need to fish by a single VM, you are growing by a single VM, and you pay more by a single VM. With any hardware-based solution, what you build in your own data center, there is no way to grow by a single VM because hardware is just not like that. If you need more VMs, you need to buy at least another physical server, which will build. It depends on the dense type what you are looking for. It may bring in 5 more VMs, 10 more VMs, or 50 more VMs. It depends how big VMs we are talking about. But there is no real like pay as you grow on a physical data center. And obviously, rapid deployment and easy management is something what we are looking after. If you are looking at the hardware, we offer a couple of type of hardware solutions. We started originally with the 400 nodes. The 400 nodes looks pretty much like other vendors' HCI solutions. So it's a 2-unit physical chassis with maximum 4 blades in it. If you are interested how it looks like in real life, we actually have one running in our booth. Basically, we have a 2-chassis, 6-node solution running currently VMware-based virtualization. So you can look at the management console, how it looks like. You can look at the cabling. You can look at how it looks like, how the chassis looks like, how the nodes looks like, and so on and so on. We added different type of nodes. So we added larger storage nodes in case if it's required. We released a new type of compute node where we are using NVIDIA graphic cards for VDI environments to be able to run a higher and denser VDI environment. And basically you can mix and match any of these compute and storage types in a single VMware environment. That's not really a limitation. From a software architecture point of view, as I already mentioned, we pretty much had the whole ecosystem before going into the HCI environment. So everything was given, we had the data services, we had integration with cloud and third-party backup solutions. We had all of these pieces. Obviously, a VMware-based solution is not very new, so customers are using VMware in production for over 10 years now, so that's nothing new there. So the only new thing we brought into this whole picture is the deployment engine. That's basically the automation which is going to install your hyper-converged infrastructure, and then after the installation is done, then basically what you are having is a working VMware environment, so you are going to manage your VMware environment with the existing well-known tools. We will talk about this later as well. So let's look at the architecture conversion. NetApp tends to have a way of going to the market when we are looking at problems, how to solve problems. In a lot of cases, we solve problems completely different way than other vendors are doing it. So we need to spend a lot of time describing what architecture decisions we made and how we build our solutions to solve exactly the same problems. For some customers, it makes a lot of headache that trying to understand how we build this thing. For other customers, it's not an issue. They are looking at the problem, they want to solve this thing to solve the problem, so it doesn't really matter. So the very original or the first type of HCI solutions is what we call the shared core model. In this, basically, the hypervisor is running on the bare metal servers, and on top of the hypervisor, the storage solution is running in virtual machines. That's obviously the easiest way to implement as a vendor. It's really easy to install because everything is an automated deployment, and it provides basically a consolidated management, so you don't really need to manage compute and storage separately. A little bit later, some of the vendors started to focus to run hypervisor and storage on the same physical nodes, some kind of shared services. It basically provides the same features and functionalities. It's just a different way to deploy exactly the same type of environment. And basically what we made a decision is to not do the shared core model or the shared physical hardware model, and we made the decision that, okay, we will simply use x86 based boxes, so Intel CPU, some amounts of memory, and SSDs inside, and we made a decision to isolate compute nodes from storage nodes. So when you pick a physical node, it's either a compute node or it's a storage node, and basically you run the hyper-converged infrastructure that way. We are still using the exactly same chassis. Inside the chassis, you can have any combination of compute nodes or storage nodes, but every single node has a purpose. So it's either a storage or a compute. It does have an effect on the minimal size of the hyperconverged infrastructure, so we cannot start with really small deployments. We cannot do like a single node or a two-node deployment, because the fact that the hypervisor and the storage is running on separate physical node, it dictates that the starting infrastructure is a little bit bigger than with other vendors. Obviously, this will drive performance, and it will make the solution running faster, and also it has some implications on the licensing as well, which sounds not trivial on the first side, but it has quite some advantages when it comes to licensing, either hypervisor licensing or maybe database licensing or application licensing. It depends on the vendor. So let's look at the performance. Obviously, today it's not really enough to have just performance, because as I mentioned, it's quite easy to build a solution. You throw in SSDs. SSDs are cheap, right? So I just throw them in. It sounds so reasonable. So you take a solution, you build in SSDs, and it will be obviously fast, because that's what SSDs are for. On the other hand, if you think about virtualization, one of the things, what the biggest headache in virtualization is that majority of the virtual machines are running for the same resources. So even if you have an all-flash based solution, you can oversubscribe the performance actually quite easily. So you start to build the VMs, and you just create the VMs and clone them, and they run. And on top of that, you may hire a junior DBA who runs some very smart operations, and you can still run out of performance quite easily, even though you are running you are running an all-flash storage. So the storage solution what we have inside the HCI has a world-class quality of service engine. It is used in service provider environments for 10 years now, in critical, business critical and mission critical environments. And basically, it's the only trick of this quality of service engine that this is not optional. So it's not like with other vendors that, yeah, we have a QoS, you may purchase it, and if you want to run it, if you don't want to not run it. Basically, this quality of service engine is implemented in a way that every single time when you create a virtual machine, you need to define the minimum and maximum performance of that specific virtual machine. So if you do the definition of the virtual machines from performance point of view, you will end up in an environment where the noise neighborhood effect is basically is not there, because every single virtual machine has a dedicated minimum and maximum performance numbers. We have an additional tricky one. If you see outside of minimum and maximum, we are using also burst number. The burst is there is that if some of the application in critical times is looking for more performance than the maximum, it can go and achieve additional performance outside of the maximum if the performance is available and if the virtual machine has credits for it. So I mentioned when you are creating the virtual machine, you basically, from a drop-down list, you select these three numbers, minimum, maximum, and burst. And obviously, we also have built-in policies available. Yes, sir?
The burst for how long is enabled?
Yeah, so very good question. So the way it works is that in normal state, the VM is collecting burst credits. So if the VM is not nasty, it's running normally, it's collecting these credits. And once the VM needs to have this burst performance, it will be available for the VM as long as they have the credit. So obviously when he starts to use the burst credit, it will be against his credit, and while the performance is available. So for example, if you have an environment where you run like 50 VMs or 100 VMs, and you are already using the maximum performance of the system, any of the VM is asking for a burst performance, it will be not available because you are already maxing out the system. But if the performance is available, and if the VM has burst credit available, and as long as the credit keeps, the VM can run against the burst. Okay. So this was built for service provider, and we have 10 years experience to run it in service provider environments. It runs quite well. Yes, sir.
So this is done, is prepared automatically or manually?
Every single time you create the VM is part of the VM creation process. So when you basically add a data, not a data store, when you add a drive into the VM, you will get this pop-up that the hey, please define. Obviously you can change it later. Obviously we are working with vWalls, so you can do policy-based management, so you don't necessarily need to define it per VM. You can do a policy and then just attach policies to VMs and reconfigure it anytime, but this is basically enforced.
Okay.
As I already mentioned, we are using vWalls. You are not forced to use vWalls, but it's highly recommended. In a traditional data store environment, it's quite tricky because like this healing on top of this room, if you so let's say in a traditional VM environment, from a storage perspective, you have no idea how many VMs are running, right? You just see the aggregated performance, and there's no real way to figure out that, okay, if there is a performance issue, which one of these 8 VMs is causing the performance issue. What we are doing is that we are integrating into the VMware API, so we are getting the numbers from the VMware. So you are defining performance on the VMware side, and then we are aggregating this performance and assigning the quality of service numbers on the storage, so it still works that way. And the option B is to run the vWalls integrations, and then every single VM has its own drives, which are basically own LANs on the storage engine, so everything is dedicated for the separate VMs. Okay. So as I mentioned, we run the compute and the storage separately, so every single node is either compute or a flash-based storage. So that means that there is a minimum configuration requirement of the HCI configuration, which is not very small. So you need to start with obviously for high availability a 4 storage node configuration, and again for high availability a 2 compute node configuration. If you know the numbers, every single one of these flash storage is capable to deliver 50,000 IOPS. So if you do the math in the smallest configuration with 4 storage nodes, basically you end up with a hyperconverged infrastructure which has 200,000 IOPS to run the VMs, which is quite massive. Obviously, as it's separated every single time when you add the compute node to the configuration, it adds memory and CPU resources to run VMs. It has nothing to do with storage. Your capacity will not grow, your storage performance will not change. Basically, these resources are dedicated to run VMs and run your applications in VMs. You can add obviously additional chassis, and then you can add storage node. Every single time when you add storage node, it's only adding capacity and performance on the storage side. It has nothing to do with the VMs, other than that the VMs obviously will be able to achieve higher performance.
And is it one flash storage node shared to many compute nodes?
Yes,
or vice versa?
Yes. And the maximum numbers are basically 32 for the compute nodes right now, and 40 for the storage nodes. So the maximum environment you can build is basically 72 nodes. Also, we are aware that the storage performance is quite massive, and you may not be able to use all the performance and capacity of the storage provided. So we support what we call the open storage model. So that means that the storage capacity and performance is available outside of the HCI on a standard iSCSI interface. So if you have other services like maybe other virtualization, another VMware cluster on a Hyper-V cluster or KVM or OpenStack or you name it, you can basically deploy the storage either through the storage graphical user interface, or you can deploy the API and automate the storage consumption even outside of the hyperconverged infrastructure. As I mentioned, the deployment or the installation of the process is done as we call the NetApp deployment engine. This NetApp deployment engine is the only new software in this configuration. Basically, what the NetApp deployment engine is doing is after booting up the configuration, it gives you a graphical user interface where you need to define a single admin password, which will be deployed across the nodes, and it will be used everywhere as an admin password, but you can change later if you want. And you need to provide a single IP range, which will be used by the deployment. So after providing these two details, the installation will be done in 45 minutes, and 45 minutes later you can start to deploy your virtual machines. For the deployment engine, there are two options. One of them is to create a new VMware infrastructure with basically a new vCenter. We are using the vCenter appliance for this. Or the other option is to integrate into an existing VMware infrastructure. So in that case, you are pointing to an existing vCenter. You need to provide the authentication details for that vCenter, and basically the HCI will join as part of the existing VMware infrastructure. So this is for day 0. So after, obviously, you install the HCI, you all of a sudden got an up and running and working VMware infrastructure. So we need to talk about day-to-day management. So the other decision we made is that we didn't want to create like yet another GUI to manage this whole thing. So we made the decision that, okay, thank you. We made a decision that the management interface of the NetApp HCI solution is going to be vCenter. The reason we did this is that the majority of the VMware admins are using the vCenter interface every day, so they don't need to learn a new tool. They just going to use what they use every day, and we basically build modules and plugins inside vCenter. So every single time when you create a data store, it will automatically show the available storage capacity. So you just create a data store like that. Everything is automated and everything is created in the backend environment. And also when you are when you are troubleshooting for different kind of issues, the NetApp management agent is pulling the storage logs, and it will insert the storage logs inside the VMware events in a chronological order. So basically, when you are doing the troubleshooting, you will find the compute and storage logs exactly in the same place. So you don't need to go like 5 different places to figure out where the logs are and how you can use it. If you wish to run, this is a new fancy thing, and if you wish to run microservices on top of VMware, this is the new big deal. We provide a plugin which is going to automate an API-based consumption for standard microservices, or if you wish to run Kubernetes or maybe OpenStack. These all work through APIs, so the consumption of the storage is going to be from application. If you have anything custom built, you may need an API. And in this case, obviously, majority of the storage vendors say that, hey, yes, we have an API. You only need to learn the software development kit and write 500 lines of code to be able to consume volumes and so on. You see an example of basically a volume create API, all its 12 lines. And and basically, if you have no idea, because the whole thing is new for you, you have a scripting or let's say Python development experience, what you can do is that you can go ahead in the GUI, click together a volume creation workflow, and in the bottom part of the GUI you can create, there's a button to create code, and it will generate the API example for you, so you can copy paste it into your code, and basically your API code is ready. So this thing is, as I mentioned, it was built for service providers, so the automation and API things are extremely advanced. For some of the flash-based features, obviously we are talking about flash-based storage, and yes, I spent 1 hour in my other presentation speaking about how flash is not cheap and how it's fast, but it's still expensive. So obviously the whole capacity of storage is accessible as a single pool, and we are using this single pool as a deduplication domain. So every single application, databases, VDI, file services, anything you run on the HCI solutions is on a single data pool, and we are using inline always on deduplication against this pool, and obviously we are also using inline and always on compression against this whole pool. For compression, we also have an additional background, a way more aggressive engine to run the compression. On a final note, because before we start to mention also the licensing advantages, that this is what I mentioned, that basically you don't build storage overnight. So what we bring into the picture obviously is an ecosystem for storage and data protection services. So this is basically a single picture containing all of the storage-based and backup-based services what we provide with an HCI solution. So obviously we have native replication, synchronous or asynchronous to another HCI or another element OS. That's the operating system of the storage-based solution. We can also asynchronously replicate to an existing other NetApp solutions. So for example, if you have ONTAP based storage solution in your on-prem, you can replicate from HCI to ONTAP, and you can create clones, you can play your DR plan, and you can do anything with it. You may know that we run ONTAP based services in public clouds. So if you wish to go to Microsoft Azure or Amazon Web Services to create your DR, you can create an ONTAP based solutions in the public cloud and create a asynchronous replication from your on-prem HCI to the public cloud and use the public cloud as DR. We are working with data protection partners. Our main focus is on Veeam and Commvault. Currently, the highest integration is with Veeam. So with Veeam, Veeam is going to create storage-based snapshots and replicating it to another nodes, or creating Veeam-based backups on the storage-based snapshots and so on. So this is about the ecosystem. The last point, the point I left as the last one is the licensing. So I mentioned in the beginning that licensing can be a challenging thing in hyper-converged infrastructures. One of them is obviously the hypervisor licensing. So you probably know that you pay hypervisor licenses based on the cores. So if you have a shared core model, that means that every single time when you need to extend your hyper-converged infrastructure, even with storage nodes, in the shared core models, you are also extending it with hypervisor nodes because you need virtualization. So that means that the storage-based expansion is going to cost you VMware licenses as well. So that's one of the licensing implications. The other issue is that, for example, if you run database, how many of you wanted or actually run Oracle on VMware infrastructure?
Only as a POC. Only as a POC.
You were not happy with the licensing, or?
They never followed that.
Okay.
Actually,
okay.
we had SAP HANA virtual.
Nice.
Not basic.
Nice. So the biggest issue with database licensing on virtualization is that some of the vendors, especially for example Oracle, they like to force you to buy Oracle licenses for the whole virtualization infrastructure, because there is a possibility that your database VM will run somewhere there. So obviously it means if we run a shared core architecture in a hyper-converged infrastructure, that any of the node which has a VMware license is going to have an Oracle license as well. And when you are extending the hyper-converged infrastructure, is going to extend both of those licenses. So these are actually the licensing advantages what we have on top of the other advantages. So that's why we say that, okay, as we have the licensing advantage and the quality of service advantage on top of the performance, basically we can offer the hyper-converged infrastructure for consolidation services, not just trying out POC or some isolated applications or running an island. If you don't have any question, then this is what I wanted to say. In 1 minute, the lady will come in and will tell me that I don't have any time left, because 9 minutes ago I got the 10-minute lump. So I'm open to questions. If you don't have any question, I'd like to mention 2 things. One of them is that we have, as I mentioned, we have a running HCI environment in our booth, so you can come down, you can look at it, how it looks like, how it's cabled, how noisy it is, or how the GUI looks like. But I already spoiled this, so it's a standard VMware graphical user interface. So there's not a lot to see on the management interface. That's one of the things. The other thing is that yes.
Can you break it and reinstall it just to see the NetApp?
I'm not sure we want to do that. So, so the installation was done by Liviu in ITPS, and I'm not sure that he would be the happiest man if I go to there and say that, hey Liviu, can you break it? Thank you. Can you break it and rebuild it just for us to see? Basically, the deployment engine, the way it looks, is quite simple. I think we should have a demo of it on the YouTube. So you can take a few minutes, search NetApp HCI on YouTube, and you will find how the NDA looks like. It's quite easy, as I said. It's a password, and basically you define the network range, what you want to do, and that's it. It will obviously, it has every fancy networking stuff. So if the DNS you provide is not DNS, it will tell you. If the time server is not a time server, it will tell you, and a lot of things. So you need to actually provide available IP addresses which are not used by another host and things like that. The other thing I wanted to mention is that Marius didn't brought any, but at the booth we have these forms, so you can leave your contact details if you are interested more about the HCI, the NetApp HCI, or you want to see a proof of concept, or you want to see pricing, because I already mentioned that it's not necessarily the cheapest thing on earth, which is generally true for all hyper-converged infrastructure solutions. And we can help you figure out that, okay, what it means from a management point of view, how the cost breaks down to per VM or per core, or how basically it's going to work out for you. So other than this, thank you so much for coming. Enjoy the remaining part of the day. We will have one more presentation, so NetApp has one more presentation at 3 p.m., which is probably the most exciting time, second day afternoon. My colleague will talk about anything data protection and encryption and GDPR and a lot of light topics for the second day afternoon, hopefully after the party, so you didn't sleep enough and you can go to a lightweight session like this. So thank you so much for coming.